The DC Supplemental Electrical Code is indeed available online. You can locate it at dcregs. DC.gov, then /sites/default/sites/sites/publication/sites/attachments/DC% 20 supplemental% 20 electrical% 20 code. PDF. The electrical code utilized by DC is not still the 1984 version. The current version of the DC Electrical Code is the 2017 National Electrical Code, also referred to as the 2017 NEC, and it is amended by the DC Supplemental Electrical Code. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It's updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The DC Supplemental Electrical Code contains amendments and additions specific to the District of Columbia, addressing local conditions and requirements. The NEC provides comprehensive guidelines covering various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It's organized into chapters and articles, each addressing a specific area of electrical work. For example, Chapter 1 provides general requirements, while Chapter 2 covers wiring and protection. Chapter 3 deals with wiring methods and materials, and Chapter 4 addresses equipment for general use. Chapter 5 covers special occupancies, and Chapter 6 covers special equipment. Chapter 7 covers special conditions, and Chapter 8 covers communications systems. Understanding the structure of the NEC is crucial for navigating its provisions effectively. Each article within the NEC is further divided into sections, providing detailed requirements and specifications. These sections often reference tables and examples to illustrate proper installation practices. When working on electrical projects in DC, it's essential to consult both the NEC and the DC Supplemental Electrical Code to ensure compliance with all applicable regulations. The DC Supplemental Electrical Code may modify or add to the requirements outlined in the NEC to address local conditions and priorities. Some key areas covered by the NEC include wiring methods, such as the types of cables and conductors permitted for different applications, the ampacity, or current carrying capacity, of conductors, which must be selected based on the load they will serve and the ambient temperature in which they are installed. Overcurrent protection, including the selection of circuit breakers and fuses to protect against overloads and short circuits. Grounding and bonding, which are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment installation, covering the proper mounting, wiring, and connection of electrical equipment, and special occupancies, such as hazardous locations, healthcare facilities, and places of assembly, each of which have unique electrical requirements. The NEC also includes tables and examples to assist with calculations and decision-making. For instance, Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. Example D3 in Annex D illustrates how to calculate the feeder demand load for a dwelling unit. The DC Supplemental Electrical Code may include additional tables or examples specific to local requirements. To effectively use the NEC and the DC Supplemental Electrical Code, it's important to understand the definitions of key terms. Article 100 of the NEC provides definitions for terms used throughout the code. Some common terms include ampacity, which refers to the current carrying capacity of a conductor, grounding, which is the connection of electrical equipment to the earth to provide a low impedance path for fault current, and bonding, which is the connection of metallic parts to create an electrically conductive path. It is essential to stay up to date with the latest edition of the NEC and any applicable local amendments. The NEC is typically updated every 3 years, and local jurisdictions may adopt these updates with or without modifications. Failure to comply with the latest code requirements can result in safety hazards and code violations. Here's a more detailed look into some of the key areas covered by the NEC, expanding on the initial overview. Wiring methods encompass a wide range of requirements for the installation of electrical conductors. The NEC specifies the types of cables and raceways that are permitted for different applications, taking into account factors such as voltage, amperage, environment, and occupancy. Some common wiring methods include non-metallic sheath cable, also known as an N cable or Romex, which is commonly used in residential wiring for branch circuits, electrical metallic tubing, also known as EMT, a thin-walled metal conduit used for both exposed and concealed wiring in residential, commercial, and industrial buildings. Rigid metal conduit, also known as RMC, a heavy-walled metal conduit used for applications requiring high mechanical strength and protection, and cable trays, which are used to support and route large quantities of cables in industrial and commercial settings. The NEC also specifies requirements for the installation of conductors within raceways, including fill limitations, support requirements, and bending radii. The ampacity of conductors is a critical factor in ensuring the safe operation of electrical circuits. The NEC provides tables, such as Table 310.15b16, that list the ampacity ratings for conductors based on their size, insulation type, and ambient temperature. The ampacity of a conductor must be sufficient to carry the load it will serve without overheating. Factors that can affect the ampacity of a conductor include the ambient temperature, the number of conductors bundled together, and the presence of insulation. The NEC provides adjustment and correction factors to account for these factors. For example, if a conductor is installed in a high-temperature environment, its ampacity must be derated to prevent overheating. Overcurrent protection is essential for protecting electrical circuits from overloads and short circuits. The NEC requires that all circuits be protected by overcurrent devices, such as circuit breakers and fuses. Circuit breakers are designed to trip and interrupt the flow of current when an overload or short circuit occurs. Fuses are one-time use devices that melt and open the circuit when an overcurrent condition exists. The NEC specifies the maximum size of overcurrent devices that can be used to protect different types of circuits and equipment. The size of the overcurrent device must be coordinated with the ampacity of the conductors it protects. Grounding and bonding are critical for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Grounding provides a lower impedance path for fault current to flow back to the source, allowing the overcurrent device to trip and to energize the circuit. Bonding connects metallic parts of the electrical system together to create an electrically conductive path. This helps to equalize the voltage potential between different parts of the system, reducing the risk of electrical shock. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding jumpers. Equipment installation covers a wide range of requirements for the proper mounting, wiring, and connection of electrical equipment. The NEC specifies requirements for the installation of electrical boxes, receptacles, switches, luminaires, appliances, and other types of equipment. These requirements are designed to ensure that equipment is installed safely and in accordance with manufacturer's instructions. Special occupancies have unique electrical requirements due to the specific hazards present in these locations. The NEC contains specific requirements for hazardous locations, such as those containing flammable liquids or gases, healthcare facilities, where electrical systems must be designed to minimize the risk of electrical shock to patients, places of assembly, such as theaters and auditoriums where large numbers of people may be present, and other special occupancies, such as agricultural buildings and marinas. In addition to these key areas, the NEC also covers topics such as low-voltage systems, communication systems, and emergency systems. It is a comprehensive document that provides a wealth of information on all aspects of electrical installations. To effectively use the NEC, it is essential to have a thorough understanding of its organization and content. The NEC is divided into chapters, articles, and sections. Each chapter covers a broad topic, such as wiring and protection or wiring methods and materials. Each article covers a specific aspect of that topic, such as overcurrent protection or grounding. Each section provides detailed requirements and specifications. The NEC also includes annexes, which provide supplementary information such as examples and calculations. It's also crucial to stay updated in the latest edition of the NEC. As mentioned, the NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important to use the most current edition of the NEC when designing and installing electrical systems. Furthermore, it is important to understand how the DC Supplemental Electrical Code amends or modifies the NEC requirements. These supplemental codes are crucial for ensuring compliance with local regulations and safety standards. They address specific conditions and priorities within the District of Columbia. Therefore, always consult both the NEC and the DC Supplemental Electrical Code when working on electrical projects in DC. By consulting and adhering to both the NEC and the DC Supplemental Electrical Code, you can help ensure the safety and reliability of electrical installations. The NEC is a complex document, but it is essential for anyone involved in the design, installation, or inspection of electrical systems. Thorough understanding of the NEC and the DC Supplemental Electrical Code is crucial for ensuring the safety and compliance of electrical installations in the District of Columbia. The 2017 NEC, as amended by the DC Supplemental Electrical Code, is the current standard for electrical work in DC.